platform. In this lesson, we'll be looking at how best we can differentiate implicit functions. So we have to know what implicit functions are. In our previous lessons, we learned how to differentiate explicit functions. So let us know the difference between implicit and explicit functions. So if I have a function y is equal to 2x squared minus x, this is what we term as an explicit function because we have isolated the y. So that the y here, which is the dependent variable, is isolated. So we isolated the dependent variable. All right. Now, when you have another function, so our function 1 here is explicit function. So this is an explicit word function. Now we have to look at implicit function. So if you have a function where the dependent variable is isolated from the independent variable, let us take this example. If I have a function in the form 2x squared minus y, 2x squared minus y minus x to be equal to 0. This function is called an implicit function. So this becomes an implicit function. So here, the dependent variable is not isolated. So you could say we have the x and y all coming together. So they have been mixed up. So this is what we call implicit function. All right. Now let's look at more examples. Let's look at more examples. If I have 2x squared y minus y squared plus 6x equal to, let's say, negative 4. This function is also termed as an implicit function because you can see that we have not made y the subject, we have not made x the subject, so we have not isolated the dependent variable. So this is also an example of an implicit function. All right, let's look at how best we can differentiate implicit functions. Now we have to revise how to differentiate explicit function. Then we will apply some of the concepts here. So let us revise how to differentiate explicit function. So let me bring explicit function. Yes, so explicit explicit function. So for now, let us revise how to differentiate explicit function. So suppose I have y to be equal to 2x squared minus 3x. To differentiate this function, we are going to write dy dx to be equal to, then you apply the power rule. The power multiplies everything. It's going to be 4. Then you reduce the power by 2. So it's going to be x. We are going to get 4x. Then minus the power of this x is 1. So when 1 multiplies 3x, negative 3x, we are going to get negative 3x. Then we reduce the power of x by 1, which is 1 minus 1. So it's going to be 0. X exponent 0 is equal to 1. Since x is not equal to 0. So here becomes 3. All right. So this is how we differentiate explicit functions. Now, another way is that you can take each of the components of the function. Suppose, so looking at this function, we have function to be y is equal to, function to be y is equal to 2x squared, then minus 3x. So you can take each of the components. So we can say that y is equal to 2x squared. Then you differentiate this one, you get 4x, which is y prime, which is the same as dy dx. Then you take the other part of the function, which is y is equal to negative 3x. All right. So when you find y prime, which is dy dx of this one, you are going to get negative 3. So you can bring the two derivatives together. So you can bring the two together to be your y prime is equal to 4x plus 3, which is the same as this. So you can say that these two answers are the same. These two answers are the same. So we'll now learn how to work on implicit functions. So let us now focus on implicit. So for me, I will start with my first implicit function, then we'll learn how to go about. We are going to apply what we just did. So meaning you take each component, then you differentiate with respect to x. All right. So let's look at the implicit functions too. All right. So let us take the first implicit function. Suppose I have y plus x to be equal to 1. Y plus x to be equal to 1. You can see that we have not isolated the y. So we have to differentiate the given function. We have to find the y dx. So this is what we are going to do. We take each of the terms and differentiate with respect to x. Now you could say the first term is we don't have x over there. The first term we don't have, so it means we are going to differentiate y with respect to y again. That's what we are going to do. So let us assume that you take just the first part to be y is equal to y, and you are differentiating. Now, is that you'll be getting the y, the x. Now you are going to differentiate y, but we don't have x here, so you need to use the chain rule. So dy dx will be equal to dy times dy dx. All right, let us look at it carefully. Because when we simplify what we have here, when we simplify this one, so this cancels this, you get back to dy dx. So this is the rule that will be using when you have the function in terms of y, and you have to differentiate with respect to x. So when you differentiate this y, you are going to get, so you are going to differentiate y with respect to y. So our dy dx will be equal to differentiate y with respect to y, which is the dy. So you get 1. Then multiplying dy dx, so it's going to be times dy dx. So that is why anytime you multiply, when you differentiate the y component, that is the dependent variable, the answer will be multiplied by dy dx. That is the derivative of the y with respect to x, the function y with respect to x. All right, so we are going to apply it. But you can say that when you take the second component, which is x, so that is y is equal to what? Y is equal to x. When you differentiate this one, you are just going to get dy dx to be equal to 1. All right. Then you take the last part of the function, which is 1. So y is equal to 1. When you find your dy dx, you are going to get back to, you get an answer of 0. So let us look at the function again. We have a function y plus x is equal to 1. When we differentiated the y, we had it to be 1 dy dx. When we differentiated the x with respect to x, that is the function y, that is y is equal to x. With respect to x, we had answer to be 1. When we differentiated this one, when we differentiated the 1 here, we had the answer to be 0. So we are going to write 0 over here. And this implies that we are going to get our dy dx, because 1 times dy dx is the same as dy dx, to be equal to, then you transpose this one to the right hand side, we are going to get it to be negative. So our dy dx from the given implicit function x plus y is equal to 1 is equal to negative 1. Let's take more examples on implicit. Suppose I have a function 2y squared minus 6x squared plus 6x to be equal to 4. And you are asked to differentiate. It means you are going to take each of the terms. So we start with the first term, 2y squared. 2y squared. So since we have y, when you differentiate it, the answer is going to be the derivative of the 2y squared multiplying dy dx as we did in the first example. But this time we are not going to repeat the same thing again. because we have now identified the the particular trick that you'll be using. So there's no need for you to be bringing all those methods here. So here will be, when you differentiate this one with respect to y. So it's going to be, you find dy. So dy, you differentiate y with respect to y. Times dy dx is the same as dy dx. So that's what we are going to do. So you get 4y, then times dy dx, which is the same as y prime. Then you differentiate this one, we are going to get 2 times 6. So it's going to give us 12x. Then here to differentiate your 6x, you are going to get positive 6. When you differentiate your constant, you are going to get it to be 0. Right. All right. Then we continue to simplify. Now we need to find dy dx. So we need to make our y prime the subject, since y prime is the same as dy dx. So we are going to get 4y multiplying dy dx is equal to, we transpose all other terms to the right hand side. So we are going to get positive 12x minus 6. All right. Then we divide through by the coefficient of dy dx. So we are going to get 4y y prime is equal to 12x minus 6. Then divide through by 4y, and here to will be 4y. All right. Then this 4y divides this, we are going to get y prime to be equal to, here we have 12x minus 6 divided by 4y. We can simplify. So you see that in the numerator we have the highest common factor to be 6. So we can bring 6 out. Then here will be 2x minus 1. So we have 2x minus 1. Then divided by 4y. So 2 cancels, or 2 divides 4, we get 2. 2 divides 6, we get 3. So we getting the answer to be 3. Then we have 2x minus 1 in bracket divided by 2y. So this becomes our dy dx. Let us take another example. If you have x squared plus, so let's take this one to be our example. That this will be c. So if you have x squared plus y squared to be equal to, let's say, 4x. How do we find dy dx? So you differentiate each of the terms in the given implicit function. When you differentiate this one, you are going to get 2x. Differentiate this one, you are going to get plus 2y. And the answer will be multiplied by dy dx, which is the same as y prime. Then equal to, differentiate this one, we are going to get 4. All right. Then we need to make our dy dx the subject. So we are going to get 2y multiplying y prime is equal to 4. Then we transpose our 2x to the right hand side. We are going to get negative 2x. So this will give us 2y multiplying y prime is equal to 4 minus 2x. Then we divide through by the coefficient of the y prime, which is 2y. Divide here also by 2y. All right. So here we'll be having our 2y divided by 2y. We are going to get 1. Then we are left with y prime, which will be equal to 4 minus 2x minus 2. Sorry, divided by 2y. Sorry. Then we can simplify it. We are going to get 2 as the highest common factor of the terms in the numerator. So here will be 2 minus x. Then you divide everything by our 2y. Then we see that these two divides these two, we'll be left with 2 minus x divided by y. So this becomes our dy dx. Therefore, our dy dx is equal to 2 minus x over y. All right. Let's take another example. So we have example D. So, so if x squared, thus we have 3x squared y minus y squared is equal to 6x squared. Find dy dx. So we have an implicit function 3x squared y multiplying y minus y squared is equal to 6x squared, and we are to find dy dx. All right. So you differentiate each of the terms in the given implicit function. So we start with 3x squared multiplying y, but you could see that we have two different variables here. So we need to apply the product rule. So we need to apply the product rule. So let us add our function again. We have our function to be 3x squared y minus y squared. Let me verify. Okay, minus y squared is equal to 6x squared. All right. Now, when you take the first term, so we have two variables multiplying each other. So we can name here this one to be your u, and you name the second one to be your v. All right. So we need to apply the product rule over here. So it's going to be 3. Since 3 is common to all of this, so 3, then open bracket nicely. Bracket nicely. Then, using the product rule, you differentiate u, or you can decide to start with v. So I want to start with u. I'll differentiate u, then I'll maintain the v. So I'll multiply the derivative of u by the v, then plus I'll maintain my u and differentiate my v. So u then v prime. All right. Then I'll move to the next one. Look at the next one. It's only y, so I can just differentiate. So I have 2y. Then I'll bring my y prime. Since I'm differentiating and I'm differentiating a dependent variable, which is the y. So the result will be multiplied by dy dx, which is the same as y prime. Then I continue to the right hand side. I'll differentiate my 6x squared. Then I'll get 12x. All right. So we continue. Here we have it to be 3 in bracket. Sorry, 3 outside the brackets rather. So let me bring. Now our v is y. So I'll bring y here. Then we differentiate our u. Our u is x. So when you differentiate u, you are going to get 1. Derivative of x is 1. So we bring it here. Then plus, we now maintain. No, x is having 2. So sorry. It's going to be 2x rather. It's having an exponent of 2. So it's going to be the derivative of it will be 2x. All right. Then plus the original u, which is the x squared, multiply the derivative of v. We know our v to be y. So you differentiate y, you get 1. But because we are differentiating the dependent variable, you multiply the result by dy dx. Then you close nicely. Minus 2y multiplying y prime is equal to 12x. All right. So you'll be getting 3 multiplying. So we have y multiplying 2x. We are going to get 2xy. Then the other side, we have x squared multiplying 1 multiplying y prime. So we are going to get x squared y prime, which is the same as dy dx. Minus 2y multiplying y prime is equal to 12x. All right. So we can now multiply through by 3. We are going to get 6xy plus 3x squared y prime minus 3y y prime is equal to 12x. Now we are looking for y prime, which is dy dx. So we group all the terms with y prime at one side of the equation. We are going to get 3x. So these are the terms. So you have 3x squared multiplying y prime minus 3y multiplying y prime will be equal to, we have our 12x here. Then you transpose this one to the right hand side. So you are going to get it as minus 6xy. All right. So we need to factorize y prime out. Since that is common to the two terms, we have y prime here, then we have 3x squared minus 3y, all equal to 12x minus 6xy. So we can now divide through by the coefficient of y prime. So we are going to get y prime multiplying 3x squared minus 3y equal to, I'm repeating the same thing for our divide. Then I'll divide this by 3x squared minus 3y. And I'll divide this side also by 3x squared minus 3y. So this cancels this. We are left with y prime is equal to 12x minus 6xy, then over 3x squared minus 3y. Alright. So we can simplify. So looking at the denominator, they all have 3. And looking at the numerator, they also have, we can divide, they also have a number that can divide 12 and 6 without a remainder. So we can factorize 6 out. In the numerators, we have 6. We can equally factorize x out. So we have 6x, and we divide the first term, which is 12x, by 6. We are going to get 2 as the result. Then we divide the second one also by 6x. So 6 divided by 6 will give us 1. X divided by x will give us 1. Then we are left with y. Alright. Then we divided by 3x squared. So we can also factorize 3 out. So let me, because 3 is also the highest common factor y. So 3, then x squared minus 3y. Alright. So 3 here 1, 3 here 2. So we are going to get 2x multiplying 2y minus, sorry, not 2y, 2 minus y rather, divided by divided by divided by x squared minus 3y. Alright. Now let's take one more example. So we are going to look at example E. Alright. So let me conclude here. This is our dy dx, which is the same as the y prime. So dy dx is equal to 2x multiplying a bracket of 2 minus y, all divided by x squared minus 3y. Let's take another question and see how best we can go about it. Now we have another one here to be 2x cubed y squared plus 6y squared minus 6xy, all equal to 6x. Alright, all is equal to 6x. Right. Now how do we differentiate this one? We have to find dy dx. We have to find dy dx. So looking at this, we need to apply the product rule. So we bring our 2 out. Then you differentiate. You name this to be your u, and this to be your v. Alright, so you differentiate your u, which is 3x, and you maintain your, 3x squared rather. You maintain your v, which is y squared. Alright, then plus you maintain your u, which is x cubed. Then you differentiate your y, and that will give us 2y. But because we are differentiating the dependent variable, we are going to multiply the result by y prime. Right, so it's going to be 2y y prime. Alright, then close the bracket nicely. Then here will be 12y, then y prime. Alright. Then here we need to apply the product rule. So bring our negative 6 out. Then you differentiate the first, we can name here to be our u, here to be our v. So differentiate the first term, our first one to be the u, we are going to get 1. When you differentiate x, we get 1, multiplying the original of the v, which is the y. Then you maintain your x plus you maintain your x, which is the value for the v, and you differentiate your v. So we are going to differentiate the y. So that will be 1. So you get the result to be 1. Then it's going to be multiplying y prime. Alright. Then that will be equal to the derivative of 6x will be 6. Alright. So we continue to expand this bracket. So here we have 3x squared times y squared. We are going to get 3x squared y squared times 2. So we are going to get 6x squared y squared. Then we have here to be x squared times 2y, and that will give us x, sorry, not x squared, x cubed plus x cubed, sorry, I beg your pardon, x cubed times 2y. So we are going to get x cubed multiplying 2y. So it's going to be 2x cubed y multiplying y prime. Then we have 2 outside the bracket, so it's going to be plus 4x cubed y, then y prime. Then plus our 12y multiplying the y prime. Then minus, we expand the second bracket as well. Let me close this bracket. So here we have negative 6 multiplying 1 times y. So we are going to get negative 6y. The negative 6 also multiplying x times 1 multiplying y prime. Alright, so you'll be getting negative 6 x y prime all equal to 6. Alright, so we need to group like terms. So we are going to bring all the terms with the y prime at one side. So I'll bring my 4x cubed y multiplying y prime, then plus 12y y prime, then minus 6x y prime, then equal to, then I'll transpose all other terms to the right hand side. So I already have 6 here. So 6 minus, I'm transposing this one. So I have minus 6x squared y squared. Then I'll level with this one. I'll transpose this one too as well. The negative 6y. So it's going to be plus 6y. Alright. So let us count the terms. We have 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. Alright. So let us factorize our y prime out. So it's going to be y prime is equal to 4x cubed y, then plus 12y minus 6x, then close bracket, all equal to 6 minus 6x squared y squared plus 6y. Alright. So we can now divide through by the coefficient of y prime. So I'll divide through by 4x cubed y. Then plus 12y minus 6x. And here to the by the same thing, 4x cubed y plus 12y minus 6x. Alright. So this divide is, we are left with only y prime, and it will be equal to 6. Now you will say at the numerator they have 6 as the highest common factor, so you can factorize 6 as so. Then after I use it to divide each of the terms, 6 divided by 6 gives us 1. 6x squared, negative 6x squared y squared divided by 6 will give a negative x squared y squared. Now positive 6y divided by 6 will give us positive y. Alright. Then you divide it by, we have 4x cubed y. So they also have 2 as the highest common factor. So we can factorize 2 out. So 2 out. Then we have here to be use the 2 to divide through. So it's going to be 2x cubed. Then we have y. Then here will be plus 6y. Then you divide negative 6x by 2 get negative 3x. Alright. So 2 divide itself 1. 2 divide this will get 3. So we are going to get y prime to be equal to 3 multiplying the bracket of 1 minus x squared y squared plus y a plus y okay plus y, then everything divided by 2x cubed y plus 6y minus 3x. So this becomes our dy dx. So let me go through it again. I'll use just 1 minute to do that. Okay, so I'm going through it again. The first step is okay. Now, okay, good. 6x squared multiplying y squared plus this. And we have group like terms. So we have our terms with the y prime at one side. So the first one with the y prime is 4x cubed y. Alright, good. 4x cubed y, good. Then the other one too is 12y, then y prime. Then the last one is minus 6xy prime. Alright, okay. And we have transposed this 6x squared y squared to the right hand side, becoming negative 6x squared y squared, which is correct. And we have also transposed our negative y to the right, so it becomes plus y. Alright, becomes plus y. And you divide through by the coefficient of y prime. Alright, and we simplify to get this as the answer. Alright, thank you for watching, and do not forget to subscribe to my YouTube channel, which is Math with MFA. So this is how we find derivative, or we differentiate implicit functions. Thank you for watching. Bye.